Objective 5 is mostly a factoring objective. There's a little bit of graphing in the end, but the method that's focused for Objective 5 is factor by grouping. Now on examples 1 and 2, the process has actually already been started for you. We look at these two terms and they do share a common factor, and that factor is W plus 2. So you always do what you always do when you find a common factor. You just divide both terms by that W plus 2. And that's my front factor, W plus 2. That's the common factor. And then for each term, you just look at what's left. That on this one, it would be the 7x. And on this one, it would be the plus 5. And there's your answer right there. Now, for example 2, these two things, some people might say, well, they're the same thing. They're not really the same thing. In fact, they're exact opposites. A minus 2 and 2 minus A are exact opposites. And you can tell because on this one, the A is positive and the 2 is negative. On this one, it's the exact opposite. The 2 is positive and the A is negative. Well, the easiest thing to do is turn this second one around. There's a quick little method to do that. So that would be, don't do anything to this first one. Leave it as 4c times a minus 2. But the way to turn 2 minus a right here into another a minus 2 is simply multiply it by negative 1. And that'll turn the 2 minus a around to the a minus 2, but it'll also do something to this plus 9. It'll make it a minus 9. It'll just change that sign. And now you're in a position like you were up here. Both terms now have an a minus 2, which is exactly what we wanted. So that's a common factor. So a minus 2 is brought out in front as the GCF. And then the other factor is 4c minus 9. Example 3 is different from 1 and 2 in the fact that it hasn't even been started. What you see is a 4-term polynomial, and if you checked for a GCF, something common to all 4 terms, you're not going to find anything. There is no GCF that's common to all 4 terms. However, if you pair up the first 2 terms and the second 2 terms, you're going to find out that something happens that's going to let you continue factor by grouping. So, if you look at the first 2 terms, they have 7y in common. The GCF is 7y. So if you factor out a 7y from the first 2 terms, you're left with 2x plus 5. Now let's move on to the second pair. They have a negative 3 in common. So I'm going to divide both of those terms by negative 3. And when negative 6x is divided by negative 3, you get positive 2x. And then negative 15 over negative 3 makes plus 5. And now look where we are. We're back to where we were in examples 1 and 2. These two terms now have 2x plus 5 in common, so I can factor out a 2x plus 5 as the common factor. And we know what happens when we do that. It just factors out in front, just like any other GCF. So 2x plus 5 is my common factor, and 7y minus 3 is my other factor. So there is the fully factored form of this 4-term polynomial. We've got a lot of work to do with example number 4. Factor and sketch the polynomial function. Be sure to label the x-intercepts and the y-intercept. Well, before we can even think about graphing it, we need to get it in factored form. So again, we have a 4-term polynomial, completely unfactored right now, but unlike the other one, there is a GCF. All 4 terms do have something in common, and that is the number 2. So, first thing I'm going to do is I'm going to factor a 2 out of every single term in this polynomial. So, 2 is the greatest common factor right now, and I'm left with x cubed minus 5x squared minus 25x plus 125. Now, I'm still left with another 4-term polynomial inside these parentheses. And I can factor this down according to our factor by grouping rules. The first 2 terms share an x squared, so I'm going to factor an x squared out of each of those 2 terms. And I'd have x squared, and then I'd be left with x minus 5. Now moving on to the second 2 terms, I'm going to factor out a negative 25. There's the minus 25 or the negative 25 that I just factored out, and I'm going to be left with positive x minus 5. And now I'm at the point where both of these terms have an x minus 5 in them, so I can factor out the x minus 5 as the common factor of these 2 terms, and I'm left with x squared minus 25. Now, let's don't forget that 2 that we factored out at the very beginning. So if I rewrite the equation where it stands right now, y equals 2 times this. But there's one more thing to notice. X squared minus 25 is a difference of perfect squares. So this can go further into x plus 5, x minus 5. There's this x minus 5 right here, and there's this 2. And so that's this equation in its fully factored form. I can clean it up just a little bit more because 2 of the factors are x minus 5. So I can rewrite it as y equals 2 times x minus 5 squared times x plus 5. So there's the equation in its fully factored form. Now that we have this problem fully factored, we can finish it off by making the graph, by identifying the important things. Number one, I now know the x-intercepts. One of the x-intercepts is at +5, and it's a multiplicity 2, which means when I do hit that +5, I'm going to turn around and bounce off it. I'm not going to pass through. The other x-intercept is at x equals -5, and it's a multiplicity 1, so I am going to pass through. I also know the y-intercept. I can go back to the original equation for the y-intercept. Because remember, you find the y-intercept by making x equals 0. Well, if you go back to the original form of the equation before it was factored, if x equals 0, that term zeroes out, that term zeroes out, that term zeroes out, and the only thing that's left is the constant. So I know my y-intercept is at 250. It's way in the heck up here. Let's just call this 250, right there. Now the last thing I need to know is the end behavior, and that's based on the highest powered term. So since the highest powered term was 2x cubed, the power or the degree is odd, and the leading coefficient is a +2. So one more time, coming back to the card, when the leading coefficient is positive and the highest degree of the power is odd, this tells me it's a low to high graph. The end behavior is low to high. Now, with all that information, I should be able to graph this graph. I'm going to start low. I'm going to pass through -5 on my way up to 250. I'm going to turn around. I'm going to come down and hit +5, but when I hit +5, since it was a multiplicity 2, I'm going to bounce off and go back up, and that's going to create my low to high. So, let's start low. Come up to 250. Turn back around. Hit 5, and go back up. And there is a representation of that graph.